Okay, we should have left off here last time, I believe. And so the ketone bodies are going to be formed for the acetyl-CoA, primarily from the liver. And right here we actually have the acetyl-CoAs. Does everybody see that okay? Acetyl-CoA. And so what's going to end up happening is we're going to join these together, and that's going to cause one CoA to come off. Now, where's this sulfur group go? Okay, so very common misconception. The sulfur's part of the CoA. Okay, the acetyl group is actually the carbon right here on. Everybody see that okay? Okay. Really, really common mistakes people make when they start on this, okay? Now, this is going to give us acetyl CoA. Notice, by the way, that acetyl with the YL, this is the substitution form of that, right? And the aceto is the other one that's attached to the carbon, okay? And so the naming actually makes incredibly good sense. Now, what's going to happen next is we're again going to get another acetyl-CoA coming in. And so we're going to do this reaction another time. We're also going to add water this time. And so what that's going to give us is we're actually going to get a carboxylic acid with this last one here, okay? Or in, a buffered system, carboxylic acid always goes to carboxylate, right? It's always going to lose its H+. And so that's going to give us our 3-hydroxy, 3-methyl-glutarate, CoA. And that's this right here. Can everybody see and identify the parts of this okay? Anybody have any issues with that? Okay. There's a few little interesting caveats. For example, the oxygen, and technically the other H would have also come over here onto this last one, which was the green one, okay? This blue one actually has the other hydrogen from that water, okay? And we're not going to go into a full mechanism like you would in organic chemistry. It's just utterly unnecessary, right? But this ends up being an alcohol, and this is the 3-hydroxy. Everybody see the hydroxy part there? That's the hydroxy. Okay. And glutarate methyl. Notice it has a methyl off of here. You all may have been wondering what was going on with this one right here. That's the methyl. Okay. All right, so what's going to happen next is we're going to go ahead and leave this. What is this group that's leaving, by the way? It's your original acetyl-CoA. You just wholesale get one of the acetyl-CoAs coming back off, okay? This is going to actually leave you with the acetoacetate. Notice, by the way, that the acetate being this group right here, right? 8 for the carboxylate. And then the aceto is over here, which is the aceto that was over here as well, okay? Now, this actually has two things it's going to split off into. It's going to make acetone, and we're going to have NADH and an H+. Remember, we can oftentimes call NADH NADH2+, right? And so this is going to give us NAD+, and this is going to give us our D3-hydroxybutyrate. Remember, the D part tells us the stereochemistry right there, okay? That's actually that same DNL that you remember from Organic 1, hopefully. This part right here, acetone, is that okay? Is that something you use a lot of? And man, that's good eating right there. No. Though, did you know that acetone was actually sold as a food during cowboy times? Late 1800s. Do you know it was sold as? Basically Tabasco. Yeah, it was like a Tabasco hot sauce that you put on stuff. Weird, huh? But yeah, you make acetone. That is poisonous, by the way. You will have to deal with the acetone. Though you also can make acetone from ingesting things like ethanol. Yes. Oh, did I zoom forward? I'm sorry.
Yeah. I was so confused. I was like,
Oh, shit. Yes, you're right. I did chapter 22:41 because apparently my eyes are not straight.
no, I was just like,
No.